Angles. Why was the angle freezing? Because it was less than 32 degrees. Okay, in this concept, we're going to learn about coterminal angles. This is probably something you've seen in Algebra 2. First of all, we're going to talk about standard position. An angle is in standard position if the vertex is at the origin and its initial side lies along the positive x-axis. So in our angle, or our example here on the left, our initial side is along the x-axis, and then the side that opens up is called the terminal side. We will have some questions later on in this concept that talk about quadrants. So here's a quick review of quadrants of a graph. The first quadrant is in the top right. That's for angles between 0 and 90 degrees. Second quadrant, top left. Third, bottom left. And fourth is the bottom right quadrant. Okay, in these examples, we're going to graph these angles in standard form. With each of them, we need to start by drawing our initial side on the positive x-axis. Then we're going to open up the angle, the degree. So in this case, it's 60 degrees. Now these aren't going to be perfect. We know if we had it going straight up along the y-axis that would be a 90-degree angle, so that's not correct. So we need to kind of angle it out about probably 2/3 of the way, and then draw a little arrow right there to show the way that it's opening. That is a 60-degree angle. Let's also note that this angle is in quadrant 1. On to problem 2, we have a 300-degree angle. So start by drawing your initial side on the positive x-axis, and now we've got to think about how many quadrants we need to go through until we get to 300. So if we go through this first quadrant, that would be 90. Keep going, that'd be 180. Keep going, we're up to 270 now. If we went all the way again, that would be 360. So we're probably going to stop somewhere right about there and draw our terminal side. Let's also make a note that this is in quadrant 4. Problem 3, this time we have a negative angle. So in problems 1 and 2, I started from my initial side going up and around. I went counterclockwise against the clock. Now we're going to go down. We're going to go clockwise since it's a negative angle. Still start with your initial side on the x-axis, but this time we're drawing down. Again, 60 degrees is about right there. That actually kind of looks more like 45, but you get the idea. And again, we are in quadrant 4. I couldn't take it anymore. I had to go back and fix it. Oh, and I have another typo. That is a negative 60-degree angle. We also have special angles called quadrantal angles. I am sure I'm not pronouncing that right, but that's the best you're going to get. Angles in standard position whose terminal sides lie along the x or the y-axis are quadrantal angles. Again, that just sounds horrible. So these would be angles like 90, 180, 270, and so on. They're all multiples of 90 degrees. So our angles look something like this. I do want to also note that it's really important for you to draw those arced arrows that I have. I have them in red here. If we didn't have them, we wouldn't know if the angle was positive or negative or how many times it goes around. Coterminal angles. These are two angles that share both the initial and the terminal side. They differ by a multiple of 360. So an example would be 45 degrees and 405 degrees. In my drawing over here, we've got, the small little 45-degree angle. 405 degrees goes all the way around and more, so that the terminal side is the same as the 45-degree angle's terminal side. So again, these just differ by 360 degrees. We can get them by either adding 360 or subtracting 360 once, twice, 3 times, however many times you want to. So here we have an example. We're going to find the least positive, that's important, least positive measure that are coterminal with each angle. So For 908, we want least positive, so we got to go lower. We're going to subtract 360 to get a coterminal angle. Now, if I just subtract 360 once, will that be my least positive? I get 548, so I can subtract 360 again. So I'm actually going to put another minus 360 on my problem. So now if I subtract 360 twice, I end up with 188 degrees. That's the least positive coterminal angle with 908 degrees. If I were to subtract 360 again, I would have a negative answer, and again, we have to make sure it's positive. For problem B, I don't want to subtract 360 because that would just be negative still. So this time, I'm going to try adding 360. I get the coterminal angle of 285 degrees. Problem C is also negative to begin with, so we're going to have to add 360. But I'm going to have to add 360, I believe, 3 times in order to get a positive answer. So we get the coterminal angle with negative 800 degrees is 280 degrees. I would like for you to pause your video, try the same problems yourself, and then restart to see what my answers are. A windmill makes 90 revolutions per minute. Hopefully you've had the opportunity to drive through Kansas at some point. Very interesting state. And you've noticed all of these windmills. I think that there's like farm fields full of them out in Kansas and Texas and Oklahoma. I drive that route a lot to see family. And these are just massive windmills. So, interesting to know that it's 90 revolutions per minute. So one of the arms of the mill goes around 90 times in 1 minute. So our question is asking, how many revolutions does it make per second? So what we need to do is we need to take those 90 revolutions that happen in 1 minute, and we need to divide them by 60 because there's 60 seconds in a minute, and see how many of them occur per second. So divide that by 60, and we get 1.5 revolutions per second. I would like for you to now pause your video and try this problem on your own. Restart the video to see how I solved it. The first thing that you needed to do was convert to hours. So we do 210 degrees in 1 minute. So if I multiply that by 60, since there's 60 minutes in an hour, that will tell me how many degrees it goes through per hour. Now the question is asking me how many rotations, so how many full 360 degree rotations are made in 1 hour. To get that final answer, I'm just going to take that 12,600 degrees, divide it by 360 degrees, and I get 35 full rotations in 1 hour.